about magnetic effects of electric current. So magnetic effects of electric current. Now I'll explain completely. So now you can see whatever we are discussing in the topic related to mainly in this topic, so magnetic properties, and next one electromagnet. So magnetic properties and electromagnet will discuss. And one more point. So here I'm considering. So whatever we are discussing now. So magnetic effects of electric current. Magnetic effects of electric current. So now we'll see. Magnetic effects of electric current. Magnetic effects of electric current. Electric current. So in this topic, so you can see magnetic effects of electric current. So here you can see if the light is incident, so magnetic related to magnetic effects. So if I am considering this is the magnet. So what is magnet? The substance which attract the magnetic material. The substance which attract the magnetic material is called magnet. Okay, so it will attract different objects related to magnetic materials. First of all, we need to understand what is magnet and their magnetic nature. So magnetic nature, everything we have to discuss. So coming to the magnet, there are two properties are there. So one is a directive property. Another one is attractive property. Second one is attractive property. So directive property is nothing but always. So always, if you suspend the magnet freely, always it shows north and south direction. Always it shows north, south, east and west. So always it shows north and south direction. Always it shows north and south direction. So that is about magnet. And so whenever you are suspending the magnet freely, so if you are taking thread, if you take a thread and hang like this, so what happens? It always shows north and south direction. Exactly it won't show like this. So it will show somewhat tilted like this. It will show like this. So then we can say. And coming to the attractive property, so if you are considering magnetic, there are two types. So artificial magnets and natural magnet. Natural magnet is magnetite. Magnetite is a natural magnet. So magnetite is the natural magnetite. So it occurs from earth crust. Magnetite is the natural magnet which so in olden days, what they will do, so when people are moving on the sea, so this magnet can lead them so towards directions. So they can go with the help of this magnet, natural magnet. So that's why it is also called lodestone. This is also called lodestone. So natural magnet is also called lodestone. Okay. So and coming to the artificial magnet, there are man-made magnet. Artificial magnets are called man-made magnets. Man-made magnets, there so many are there. So bar magnet, U-shaped magnet, dumbbell-shaped magnet, and spiral magnet. So like that, there are so many number of according to our requirements, we can make the magnet shape. Depending on the requirements, so it depends. So we are taking only bar magnet. I am considering in the today class I will explain about bar magnet. It is an artificial magnet. It is an artificial magnet. So man-made magnets are called artificial magnet. So if you are considering artificial magnet, see, still it has to same properties, attractive property and directive property. So attractive, so directive property in the sense, if you suspend the magnet, always it shows north and south direction. Always it shows north and south direction. So that is about magnetic property. And if you are considering here, this the bar magnet, I'm considering this the bar magnet. I'm taking this a bar magnet. So the bar magnet has two poles. If you break it any, see, I'm taking this one. If you break this piece, suppose if you take it as a magnet, if you break into two pieces, still there existed two poles. There existed two poles. Two poles it will exist. Two poles it exists. That is called north and south. Okay. So here I'm considering the north. Here I'm considering the south. Here I'm considering the north. Here I'm considering the south. Okay. So here magnet has two poles. They have equal strength. Magnet has equal strength. North pole and south pole, both the poles have equal strength. Both the poles have equal strength. Both the poles have equal strength. So if I am considering here around the magnet, so the magnetic field will be there. So what is magnetic field? So first point I'm considering, what is magnetic field? Magnetic field is nothing but, so the region around the magnetic field. So magnetic field I'm considering the region around the magnet in which the magnet will influence the force, or the magnet will affect, or the magnet will attract the magnetic materials. The region around the magnet in which magnetic exert force, magnetic acts force on magnetic material. So that is called magnetic field. That is called magnetic field. So here until a certain distance only, if you are taking this magnet, until certain distance only it can attract. So if you are taking nearby it can attract. If you are taking beyond the point, it won't attract. So within the certain region only, the magnet will attract the magnetic material. 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 So the region around the magnet in which magnetic force exert, that is called magnetic field. That is called magnetic field. That is called magnetic field. So the magnetic field will be in the form of field lines. The magnetic field will be in the form of field lines. So here I am considering around the magnetic field will be there. So the magnetic field you are considering here, so this is north to south, and from here to here also south, north to south, and here I'm considering one more line. I'm considering here, so here also I'm taking one more line. Here you have to understand one thing. So when the light ray is okay, so the magnetic field around the magnet will be in the form of magnetic field lines. The magnetic field, okay. So we know the magnetic field will be there around the magnetic field will be there. How the field will be there? Okay. So how the field will be there? Normally, so the field will be in the form of field lines. The field will be in the form of field lines. How the field lines will be there? So the magnetic field lines, you can see the magnetic field lines. So those field lines will move from north to south. Those field lines will move from north to south. Those field lines will move from north to south. Those field lines will move from north to south. So whereas, so another, like here, we can observe one thing. The field lines will move from north to south. Outside of the bar magnet, the field lines will be from north to south. Inside of the bar magnet is the field lines will be south to north like this. So outside of the bar magnet is the magnetic field will be from north to south. Inside of the bar magnet is the field lines will be here I'm considering. Okay, so outside of the bar magnet you can observe these field lines will be from north to south. Outside of the bar magnet the field lines will from north to south. Inside of the bar magnet is the field lines will from south to north. the field lines from south to north, south to north, south to north, south to north. Okay, so the region around the magnet in which magnetic force exert is called a magnetic field. So if I want to find the direction of the magnetic field at this point, if I want to find the direction of the magnetic field at this point, you can draw the line, you can draw one line. So that is a tangent, tangent to the magnetic field lines. Then at that point, because the direction of the magnetic field around this one, so the direction of the magnetic field around like this, so that's why I'm taking the tangent along the direction, the tangent along the direction. So at the point here, at this point, the magnetic field will be along the direction from north to south. Okay, so the field direction at this point is along this direction. So if you are drawing here, hi Shivani, how are you? So welcome to the class. So attendance mark, very good. So here at this point you can see at this point the field lines direction can be identified by drawing the tangent to the magnetic field lines. Okay, so these are the magnetic field lines around the magnet. These are the magnetic field lines. So the magnetic field lines are so around like this. We can observe here, these are the magnetic field lines. So I want to find out the magnetic field here. So I want to find out the magnetic field here. So anyway, magnetic field will be like this, right? So at that point, the direction of the magnetic field, if you draw the tangent, so if you are taking the curve, if you draw the tangent to the curve, so if you are drawing the tangent to the curve, tangent. So tangent is nothing but the line touches the curve at one point. The line touches the curve at one point. So, sir, what topics did you cover in the chapter? Can you summarize? Normally, so just now I'm just now only started only for nearly 5 to 10 minutes. So in that I'm explaining about magnet. Magnet has property. So directive property and attractive property. Directive property means if you suspend the magnet like this, always it shows north and south direction. And attractive property is nothing but north pole repel, north pole, south pole attract. So two different poles will attract, two similar poles will repel. So that is about attractive property and directive property. Next one I discussed about artificial magnets and natural magnet. Natural magnet is magnetite. Magnetite is a natural magnet. So that is it occurs from earth crust, and in olden days people were moving on the sea, right? Some that time, so they can't able to identify the direction. They can't able to identify the direction. For identifying the direction, they will use this stone. This is a natural magnet, right? It occurs from earth crust. Okay, so they will use that stone. That's the reason it is also called lodestone. Natural magnet is also called lodestone. Nothing but magnetite. Okay, so now until that one I explained, and coming to the artificial magnets and man-made magnet. Artificial magnet, natural magnet already completed. Coming to the artificial magnet, under artificial magnets, so bar magnet, cylindrical magnet, U-shaped magnets, so like that. We can take different types. We can according to our requirement. Sir, if the compass shows north, it is possible to understand south too. But what about east and west? East and west we have to remember. East this direction, south this direction. Okay. So if you are standing along this direction, if this is north, so upper portion is north, lower portion is south. Then our right hand it is east, so and left hand like that. Okay. So one direction if you know, automatically to another direction, so we can identify it. So that's why compass is used. North and south, the remaining directions automatically we can understand. Okay, so now we can take, so the line is like this is the line. So this is the north and the south, and indications, directions, east and west. So okay, so here you can see. Now the next I'm discussing about magnetic field of bar magnet. magnetic field of bar magnet around the magnet. So the region around the magnet in which magnetic force exert, the magnetic force will be in the form of field lines. The magnetic force will be in the form of field lines. So here around the magnet, like the field lines will be like this, the field lines will be like this. So the magnetic force will be in the form of field lines. The magnetic force will be in the form of field lines. Okay, so these are the field lines along at the point, at this point. So the direction of if you draw the tangent, so here around the magnet, see normally if you take two magnets, if you take two magnets until certain range only, until certain distance only, these two magnets will attract. So beyond the point it won't attract. So until certain region only, until certain region only, the magnet will exert the force. The magnet will exert the force. The region around the magnet in which magnetic force exerts, the region around the magnet in which magnetic force exerts, so that is called magnetic field. That is called magnetic field. That is called magnetic field. So at this point, anywhere if you consider the field, the magnetic force will be in the form of field lines. These are the field lines. So field line direction will be north to south. North to south. There is a one activity is there, activity. So this chapter completely based on activity. So there is a compass. If you place the compass near to this one, compass is nothing but it is a small magnetic needle is present inside of it. So it is also small magnetic needle. It always shows north and south direction. So if you place the compass here, okay, it shows like this. So this is south, this is north. So south north will attract. As we know, opposite poles will attract, similar poles will repel. Here compass I placed and one more compass I placed here. So this is north, again this is south and north. So this will attract both, again like this. So if you keep on change the position and mark the positions of compass, then it shows the direction like this. So then it shows the direction like this. So that's why this is the free north pole direction. Free north pole direction with by using compass. Okay, so here if you take this is north and this is south. So if you consider this is the bar magnet. So I am placing here. This is the compass. Next position we have to place here. Again here. Again here. Again here. Again here. So then you can join all those positions. If you join all those positions, then you will get this magnetic field lines direction. Magnetic field direction. That is nothing but free north pole along the direction. So, and one more thing here you need to understand. So the magnetic field lines are leaving the north pole and reaching the south pole. Magnetic field lines are leaving the north pole, reaching the south pole. So from this point, the magnetic field lines are moving away from it, and to this point, magnetic field lines are reaching. Magnetic field lines are reaching. So outside of the bar magnet, outside of the bar magnet is magnetic field lines are from north to south, north to south. Inside of the bar magnet, inside of the bar magnet, south to north. So if you are placing on magnet, so this is the magnet. If you place compass on it, if you place compass on the magnet, then it shows north pole this side and south pole this side, because so direction of the field lines from south to north inside of the bar magnet. Outside of the bar magnet is so north to south. Okay, so this is about the field and field lines, and how it will be outside of the bar magnet and inside of the bar magnet. How can we identify the field lines and how can we identify the poles? In exam hall, they will ask the questions like this. So they will give, I will draw a diagram and you can identify the diagrams. So how the poles will be, how the poles will be there. So I'll draw the diagram. Just check once. So here I am drawing like this. I am drawing like this. So this is a pole, one pole, and this is another pole. So I am taking P and Q. So you can take some X and Y. So like that you can take. So here, from here, field lines are moving like this. From this, field lines are moving like this. So the direction is from P, it is like this, and Q is this like this. So what is P? What is P and what is Q? Can anyone comment? What is P? What is Q? Shivani, can you tell me what is P? What is Q? So actually P is North Pole, P is North Pole, Q is South Pole. Q is South Pole. As I already said, when I'm explaining the topic, I said, so here, outside of the bar magnet, I'm taking outside, it is not inside. So this is north and this is south. So the field lines will be from north to south will be like this. The field lines will be from north to south will be like this. So north to south, north to south, north to south here. So from this point, from North Pole, the field lines are moving away. And towards the South Pole, the field lines are reaching. So that's why here this point is called north and this point is called south. So we need to check once how the field lines are moving. If the field lines are moving away from it, that is North Pole. If the field lines are reaching to the point, that is called South Pole. If the field lines are moving away, that is north. Field lines are reaching to the point, that is called south. Best example, in the evening time, you are leaving the school and college. So school or college, you are leaving, that is north. So in the morning time, you are reaching. So in morning time, you are reaching, no, that is south. That's enough, simple. Okay, so your field lines. Okay, so coming to the electric current also, I said the same example, right? Okay, so same thing here also. If you are leaving that place, that is north. Simply you can remember, if you are leaving the place or leaving the pole, that is called, if magnetic field lines are leaving that pole, that is called north. If magnetic field lines are reaching to that point, that is called south. Okay, so this is north and this is south. This is north, this one is south. North and south, so north here. So I'm taking here this type of diagrams, they will give an exam. And they will ask about what is P, what is Q. Identify what is P, what is Q. And one more diagram I will draw. So just let me know. So related to magnetic field, this type of questions they will ask. And one more thing. So they won't ask directly. They won't ask about directly question. So two opposite poles attract each other. Two similar poles repel each other. So if I am taking north and north, similar poles repel. So repel. Coming to the north and south, will attract. So even electrical charges also. Coming to electric charges, when I am explaining the electric current, so charges also same. Two similar charge will repel, two dissimilar charges will attract. So here I am considering one more point. So I'm going to ask one more point. I'll draw the diagram now. So I'm drawing the diagram here. So this is the diagram and this is the diagram. So from here to here, the field lines are moving like this. Can you tell what is this pole? So what is this pole and what is this pole? So if the field lines are moving like this. So what is P? What is P and what is Q? So here P is North Pole and Q is South Pole. Because magnetic field lines are leaving this pole, magnetic field lines are reaching this pole. So that's why this P is called north, this Q is called south. And one more diagram I'll draw. Just identify the diagram. And what is what. So here I'm considering like this. Now you say, what is P, what is Q? So P what? P is what? And Q is what? And coming to X is and Y. What is P? P is north. Both are north only. This complete set is north. And here P is north, Q is north. And coming to X is south and Y also south. Sir, how can you say like that? How can you say like that? It is very simple, no? So if the field lines are moving away from the pole, that is north. If the field lines are reaching to the pole, that is south. Simple. Very easy. Clear? So next one, I'm going to the next one. So magnetic field is completed. So magnetic properties, everything. And here, one more point, magnetic field lines. So we have to talk about properties of magnetic field lines. 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 Magnetic field lines. Okay. Properties of magnetic field lines. Okay. Chal. So it will go. Okay, done. So I'm here. I am here only. Okay. So magnet properties of magnetic field lines. So actually I'm taking this bar magnet. So here first point is magnetic field lines are closed loops. Magnetic field lines are closed loops. Magnetic field lines are closed loops. And coming to the second point is magnetic field lines are closed loops. They will start from North Pole and reaches to the South Pole. Magnetic field lines direction, magnetic field lines direction, magnetic field lines direction, magnetic field lines direction, magnetic field direction is from north to south, Okay. So inside of the bar magnet, magnetic field lines direction from south to north. Are you understanding? Magnetic field lines direction outside of the bar magnet is north to south. Inside of the bar magnet is south to north. Don't tell to anyone. Keep it safe. So in exam hall you will write. Okay. So magnetic field lines direction north to south. Outside of the bar magnet, inside of bar magnet is south to north. One more thing, these lines never intersect. Never intersects. Never intersects. Why? Two close best enemies will not meet. Okay, if they meet, fighting will happen. Here also same thing. So that is not that fighting here. So if two lines intersect, so what happens? So generally magnetic field lines never intersects. If these two lines intersect, so what happens? At the point of intersection of compass should show two directions. Where it is not possible. Compass cannot show two directions at a time. So if you are taking this direction, it should show this direction only. It cannot be shown two directions at a time, right? So that's why here those magnetic field lines never intersect. Sometimes I will feel what I will feel, no. So because of it is not showing, these lines are never intersect. There is a logic here. What logic? Generally, these magnetic field lines never intersect. That is a true point. But if it is intersect, so one more condition they will give. If it is intersect, so compass should show at the point of intersection two directions at a time. Generally, it is not possible. Compass cannot show two directions at a time, right? Compass cannot show two directions at a time. So, because of compass, these lines are never intersect. How sad it is, and because of that clash, two enemies never meet. So, those questions will answer. Okay, only time will answer to these questions. We'll see. So, leave to the time. So, we'll come to the point. So closed loops. So closed loops, closed loops, closed loops, closed loops. Magnetic field lines are closed loops. Magnetic field lines are closed loops. Magnetic field lines direction outside of the bar magnet is north to south. Inside of the bar magnet is south to north. Outside of the bar magnet is magnetic field is north to south. Who said like that? Magnet compass is giving the direction. What is that? Outside of the bar magnet, magnetic field lines are north to south. Inside of the bar magnet is south to north. South to north. South to north. South to north. So, magnetic field lines are closed loops. Magnetic field lines direction will be north to south outside of the bar magnet, south to north inside of the bar magnet. So these field lines never intersect. If it is intersect, so compass should show two directions at the point of intersection. Where it is not possible, is it? Okay, done. So this is about properties of magnetic field lines. Now I will explain about one more point. So I am going to explain. I am going to explain. I am going to explain. So what I'm going to explain next topic. Come on, anybody guess, 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 guess. Anybody can guess the next topic. Anybody can guess the next topic. I will only guess. I am there, no? I am also a participant. I can guess the topic. The next topic is current carrying conductor. Very nice. So here I am considering the current carrying conductor. Sir, here current is passing through the conductor. What happens? What happens? The current is passing through the conductor. What happens? So tell me what happens. If the current is passing through the conductor, what happens? In 6th class, 7th class, 8th class, we did one experiment. That is taking the iron nail, wounding the copper wire, connect to the battery, it acts as a magnet. That is called electromagnet. What is that? Electromagnet. Taking the iron nail, taking the copper wire, wound around it, connect to the battery, current will pass through it, it acts as a magnet. Here also same thing, if the current is passing through the conductor, it acts as a magnet, that is called electromagnet. If the conductor is acting as a magnet, then magnetic field will be there. Yes or no? Magnetic field will be there. Yes or no? Yes or no? Yes or no? Yes. Magnetic field will be there. So how the magnetic field will be there? How, in which direction it will be there? How can I identify? How can I identify the magnetic field direction? You are saying current is passing through the conductor, it acts as a magnet. How can I identify? How can I identify how, in which direction the magnetic field will be there? If they ask in the exam, so you can write like this. There is a rule to identify the magnetic field obtained around the conductor. Magnetic field is produced around the conductor. To identify the direction of the magnetic field, we can use right hand thumb rule. What is that rule? Right hand thumb rule. I will explain that. So first we will go to this one. So current is passing here. So current is passing through the conductor. Current is passing through the conductor. Current is passing through the conductor. So current is passing through the conductor. Yes, yes, yes. So everybody listen here. Current is passing through the conductor. Okay, okay, okay. Current is passing through the conductor. After that, what happens? Magnetic field will be produced. How the magnetic field will be there around the conductor? How we can identify? Yes, yes, yes. There is extraordinary question is that one. We can use the compass. We can use the compass to identify the direction of the magnetic field. In which direction of the magnetic field? So normally around the conductor, if the current is passing through the conductor, this is the straight conductor, current is passing through the conductor, magnetic field will be produced around the conductor. So then, so if I am taking this, see, normally you, this what is, sir, what is this one? You did that box. Actually, this is a sheet of paper. So if you are taking this conductor, current is passing through that one. So if you are placing the paper here, so generally, so make a hole and place. If you sprinkle the iron particles, if you sprinkle the iron particles over it, if you sprinkle the iron particles over it, around the conductor, if you sprinkle the particles, then what happens? The magnetic field will be created. The magnetic field will be produced around the conductor like this, around the conductor like this. So by using compass, so if you place the compass here, if you place the compass here over it here, if you place the compass, the deflection can be observed. The deflection can be observed. Sir, sir, how it will be, sir? If the current is passing through the conductor, compass will show the deflection, sir. Yes, Hans Christian Oersted. So scientist Hans Christian Oersted give observe that what is that when the compass is placed nearby a current carrying conductor, so magnetic field will be produced around the conductor. Because of the magnetic field, the compass should show the deflection. Okay, that time, so Hans Christian Oersted given the relation. What is that relation? There is a relation between current and magnetism. Current and magnetism. Very good. Very nice. So we understood now, right? We understood that one, right? So this is a current carrying conductor. Current carrying conductor. Okay, so current is passing through the conductor. So he given that relation. So here the compass will shows the deflection if you place the current nearby current carrying conductor. Here two more points I'll discuss. Two more points discuss. First point is if the current is passing through a conductor, it acts as a magnet. Second point is, so second point if you are taking, second point if you are considering, so near to the conductor, the magnetic field, the magnetic, like if you say magnetic materials, actually these are the iron fillings, small iron fillings. Those are called magnetic materials. If you sprinkle the iron fillings, those iron fillings will be closely associated. Those are called concentric circles. Concentric circles are nothing but around the conductor, the concentric circles will be there. So near to the conductor, so the more iron fillings will be there. If you move away from the conductor, so the iron fillings attraction will be less. By this observation we can conclude that, so as we move away from the conductor, magnetic field will be less. As you move near to the conductor, magnetic field will be more. If you move near to the sun, so it is very hot. If you move away from the sun, you will freeze. So you have to maintain certain distance. Here also, so that's normal. So here I am considering near to the conductor, magnetic field will be more. So magnetic force also will be more. So around the conductor, concentric circles. So the magnetic field lines, So the magnetic materials will be arranged in the form of concentric circles, So here at this point, the concentric circles will be less. So as you move away from the conductor, magnetic field will be less. As you move near to the conductor, magnetic field will be more. Okay, so that is the point. So very, very important. So make sure that these points you are learning. And next one, how can we identify if the current is passing through the conductor? So here the chapter name is only this one. Till now we discussed about magnetic field lines, and properties of magnetic field lines. Everything we discussed. So here this explanation gives the definition or meaning of magnetic effects of electric current. When the current is passing through the conductor, it produces magnetic effect. So you can see I am taking the current. So this is the current carrying conductor. So if you consider this is the current carrying conductor. So if you place thumb along the direction, how the magnetic field will be there? In which direction the magnetic field will be there? By using right hand thumb rule. So this is my right hand. So this is the right hand thumb. Okay. So palm. So if you are taking this right hand, if you place thumb along the direction of the current, and curly fingers, folding fingers, wrapping fingers, curly fingers, folding fingers, wrapping fingers, shows the magnetic field. If you take the thumb along the direction of current, if you take the thumb along the direction of current, curly fingers, folding fingers, shows the magnetic field. So magnetic field will be like this. Magnetic field will be along this direction. So if it is like this, we can sometime they will ask about related to north and south, east and west, 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 north and south, east and west. Sir, what is north and south and east and west? We are singing song. We are discussing the concept. No, generally, north and south and east and west is there. So with the help of those, we can identify the direct magnetic field around the conductor. That's why I'm singing the song. So okay, fine. Come to the point. So this is the conductor. So current is passing through that one. The magnetic field, how can we identify? If you wrap the fingers, if you fold the fingers along the direction, the current will be there. So I will ask one question. Okay, I will ask one question. Shall I ask one question? I will ask. So whether you respond, whether you say yes or no, I will ask one question. So you can see now here. So I am taking this as a conductor. Current is passing in this direction. How the magnetic field will be there? In which direction magnetic field will be there? In which direction magnetic field will be? Say yes. Which direction? It will be north to south. So we are wrapping, right? So it is a top to bottom. If you are taking like this, current is passing upward direction. So east to west. If I take the current in this direction, so like this. So I am taking like this. So along this direction, current is, if you are wrapping the fingers, so current is downward direction. Curly fingers will be like this. Sir, it is clockwise direction or anti-clockwise direction? Clockwise direction or anti-clockwise direction? So if you are taking like this, so current is passing. So I am taking like this. So point of view you can see in this point of view. So this is a clockwise direction. Right? So if I take like this, anti-clockwise direction. So based on this one, it is very easy, very, very simple and easy. At the same time, easy to forget, easy to do mistakes also. Easy things are not so easy until you do it. Huh? What a quotation. So thing is, easy things are not easy until you do it. If you do it, it's easy. If you are not, it's a difficult things only. Studying is easy or difficult? Easy only. But if you are not doing, it's difficult. Any work easy or not? Any whatever work you do, so it is easy or not? If you do, it is easy. If not, it's appears difficult. Physics easy or not? Easy only. Until you do it, if you learn, it's very easy. Yes or no? Okay, done. So according to the conductor, by using right hand thumb rule, so by using right hand thumb rule, we can identify the magnetic field direction. So by using right hand thumb rule, we can identify the magnetic field direction. So next one, we can go to the, where we'll go? We will go to the loop question, next one. So I'm taking the loop. So this is the loop. Loop, 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 loop. Okay, so this the current is passing like this. Current is passing through the conductor. It acts as a magnet that is called electromagnet. Electromagnet, electromagnet, electromagnet. What is electromagnet? When the current is passing through the conductor, it acts as a magnet. It produces the magnetic field. It behaves as a magnet. So that is called electromagnet. That is called electromagnet. So if the current is passing like this, so around this place. So here, sir, I have one question. What is that question? Sir, magnetic field will be more at the circumference or in the middle? Okay, so the answer is, so the magnetic field will be more at the center than at the circumference. Sir, why, sir? How you are saying? So magnetic field is more at the center than at the circumference. How can you say, sir? How can you say? Tell me, let me know. How can you say like that? So the reason is, we know the right hand thumb rule. When the current is passing through the conductor, magnetic field will be reduced. By using right hand thumb rule, we can identify the magnetic field direction. Yeah, sir, we know that one. But, sir, I have one doubt, sir. Sir, you said at the center, magnetic field is more than at the circumference. How it is possible, sir? How it is possible? Because at the circumference, the current is passing. No, where the current will pass in the middle. How the current will pass in the middle? How the magnetic will be more? Correct only. Current is passing in the wire only. It won't pass in the air, right? If it pass, will long back only. Maybe in future it may happen, but right now it's not happening. But a current will pass in the air only. So sorry, current is passing in the wire only. Yes or no? Yes or no? Yes, current is passing the wire. Very good, sir. Correct. That is correct, sir. Whatever you said, I am 100% agree, sir. But my question is, so at this circumstance, so the magnetic field is more at the circumference or at the center? That is my question. Okay, very good. So our question is extraordinary, marvelous, and mind blowing. Here you can see the current is passing in the wire. So here magnetic field will be there. So if the current is passing like this, so here it is leaving, here it is reaching, and here it is leaving, and here it is leaving, here it is reaching. Okay, that is until this one agree? Yes, sir, I agree this one. Very good, sir. And if the field lines, as you move away from the wire, the field lines become parallel lines. Sir, that is also I agree, sir. Okay, so you agree to that point? Yes or no? Yes. So if the field lines are parallel, what happens? So if you are taking the parallel lines here, so this magnet will add to this magnet. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sir, why you are writing numbers, sir? Those lines considered as the magnetic field lines. Okay, sir. So here this magnetic field is added to this one. This magnetic field is added to this one. This magnetic field will be added to this one. So the magnetic field will be add up to each other. So here magnetic field will be there at the center. No. So what happens? Those magnetic field lines will add up to one and another. So one and another. Then what happens? See here uniform magnetic field will be there. So more magnetic field. Teamwork is greater than, teamwork is better than, teamwork will give good results than individual results. Same thing here. Okay, so if all lines add together, the magnetic field will add up. The magnetic field will be add up here. So at this center, at this center, at this center, at this center, center, at this center, magnetic field will be more compared to the circumstance. Compared to the circumstance, magnetic field will be more at the center. Sir, thank you so much, sir. I got full clarity on this loop question, sir. Okay, done. I will go to the next question. Shall I go to the next question? Sir, very good, sir. So thank you so much, sir. You can go to the next question. Okay, done. So this is the loop. Then I'll go to the solenoid. Very extraordinary question. Extraordinary question. So I will explain now how it is. Extraordinary question. How it is? Extraordinary question. The question is extraordinary question because in the board exam that question will come for 3 marks. In the board exam that question will come for 3 marks. So next target I am going to explain about 3 marks question. Very important. Very. So one story is there. So one person is writing board exam, 10th class board exams. So every day he will wake up at 5 o'clock and read. So every day he will wake up at 5 o'clock. Every day at 5 o'clock he will wake up and read. So after 1 year, so he couldn't, pass in the exams, and father so father realized that, and what he is doing, so he woke up at 5 o'clock and observe this person. That person is telling, so every day he'll wake up and say, long ago, long ago, long ago, long ago, long ago, long ago. There is a story long ago. So one person came and said to another person something. That person heard that something and informed to him something. So he is saying long ago, long ago, long ago, long ago. He is telling the same, repeating, reading the same story. So how it will pass? So we have to cover all subjects, right? So come to the point I am taking. So the moral of the story is nothing. So simply just for like that I said. So I am considering here. Here I am taking the straight conductor, straight loop. I fold it. So normally if you take a thread or wire, so wrap around the cylinder, around the wire in the form of cylindrical shape. So wrap like this, like this. Then you'll get like this. Ta-da-dang. Okay. So then we are connecting to this. Yes. I'm connecting to the battery. Shall I connect with your permission? Yeah, you can connect, sir. So I'm connecting like this. Oh my god. Here. Here. So I'm taking the battery. Oh, battery switch. This is switch. This is a battery. So current is passing. Yes or no? If you are connecting to the battery, current will pass or not? Yes, current will pass. It will act as a magnet or not? Yes, it act as a magnet. Magnetic field will be or not? Yes, it will be magnetic field. So I am taking the lines. How many lines I have to take? Give me the count. 1, 2, 3, 4, 5, 6, 7. How many lines? I am taking either 5, 7, 9, 11. Odd number. So why I am taking odd number? Because I am taking lines. 3 lines. Fourth line, fifth line, sixth line, seventh line, eighth line, ninth line. Very good. So 9 lines I consider. 9 lines. So 3 lines at the top. 3 lines at the top. And 3 lines at the bottom. Bottom. I am taking below like this. And here you can take 3 lines. Here also 3 lines. So in middle, it will become parallel lines in middle. So I'm taking the current direction like this. So here also current direction. Current direction. Current is passing from positive to negative terminal. That is called conventional current. That is called conventional current. If the current is, charges are moving from positive to negative, that is called a conventional current. If the charges are moving from negative terminal to positive terminal, that is called electric current. So here charges will move. What type of charges? Positive charges. Protons will move from positive terminal to negative terminal. Electrons will move from negative terminal to positive terminal. Negative terminal to positive terminal. Positive terminal to negative terminal is conventional current. Negative terminal to positive terminal is electric current. Electric current. Electric current. Trun, trun, trun. Electric current. Trun, trun, trun. Conventional current. Trun, trun, trun. Conventional current. Trun, trun, trun. Electric current. So what is conventional current and electric current? Conventional current means nothing but flow of positive charges. Electric current is nothing but flow of electrons. Okay, so whatever it is. So why we are discussing on this point this much? Because direction is very important. Direction is very important. So I'm taking this is south. This is north. I'll tell one secret. Keep it with you only. Don't share to anyone. The secret is, if the current is passing to that conductor, that side we have to take south. If the current is leaving to the side, that is called north pole. Keep it safe. This side is south and this side is north. Okay. Yes. So this I am taking north and this I am taking south. Current is passing. So magnetic field also, here it is leaving the magnetic field from north pole. Everybody be alert. Magnetic field is reaching to the south pole. Everybody be aware of that. So we have to announce that. What is that? Magnetic field is leaving the pole, that is called north pole. Magnetic field is reaching to the pole, that is called south pole. That is called south pole. Here is the north pole, here is the south pole. Here is the North Pole, here is the South Pole. Magnetic field lines start from north, reaching to the south, reaching to the south. And here you can observe this one. Okay, and here the magnetic field is moving inside, south to north, outside, north to south. Magnetic field is moving from north to south, reaching to south to north. Yes, so I hope you heard these points from one concept, that is magnet. What is that magnet? Bar magnet, bar magnet, bar magnet, bar magnet, bar magnet, bar magnet. Yes. So the property of the solenoid is similar to the bar magnet. So, and here one point is, so few dissimilarities also there, but similarities to take. So this solenoid has, sir, what is exactly solenoid? If you are taking the straight wire bent in the form of cylindrical shape, connect to the circuit, so it act as a magnet. Magnetic field will be produced by this one. Okay, so that's why it is called solenoid. Okay, so now here one point is, so I'm taking the bar magnet here, bar magnet north pole and south pole. Here bar magnet magnetic poles are fixed, whereas solenoid magnetic poles are not fixed. It can be interchanged. If you change the battery current direction, if you change the current direction, automatically magnetic poles will changes the direction. And here the bar magnet field is fixed. Here solenoid magnetic field can be increased or decreased by changing the battery. Okay, so voltage if you change, it also changes not only strength of current, it also changes the number of rings. If more number of rings are there, more magnetic field will be there, and the gap between the rings also, so it provides the magnetic field, more magnetic field. Okay, so this is about uh, similarities and dissimilarities, comparison between bar magnet and solenoid. I hope so we discussed few uh, few questions, few questions with answers. So I hope it is clear to you all. So if you have any doubts, you can comment in the comment section below. So this is Shiva sir from Student the Brand. So again, I'm starting one new uh, like announcement. So I started the course. That is a course like CBSE grade 10 physics. CBSE grade 10 physics, light reflection, refraction, human and color board, electricity, magnetic effects of electric current. These 4 chapters I will explain. And notes I will provide. So 100 definitions from these 4 chapters, 100 electricity problems. I will provide all this in the form of soft copy. So with the cost of 500 rupees. Those who are interested, you can contact to this number 9849812804. So this is the class for today. I'll join to the next class tomorrow. If you have any doubts, you can comment, you can ask, you can send a message, okay, in the WhatsApp or in the. So if you want any classes, any tuitions from 6 to 12, so tuitions are available for all the subjects. I'm going through the tuitions are available for all subjects from 6 to 12, all subjects. So if you need tuitions, you can contact to this number. Okay. So if you contact this number, you'll get tuitions for all subjects. So this is your Shiva sir from Student the Brand. Until that time, signing off. Namaste. See you.